Welcome to Breadboarding. This is part 2 of video 13 of the Breadboard video controller series, and in this part what we're going to be doing is enabling the configuration of switching between video modes be configurable by software rather than hardwired in the breadboard configuration itself. So in the last video, in part 1, what I did is covered the overall design of the 320 by 200 color graphics, and in order to do this what we need to do is use some programmable logic devices to provide a multiplexer for the various character modes for both accessing the CPU address and the CRTC address. So what I'm going to cover here is how we're going to be swapping out some of the existing buffer chips for the various Atmel programmable logic devices. If we have a look at the configuration spreadsheet that I shared in part 1, you can see here that we're first going to look at the video RAM CPU address 1 multiplexer. What this is going to be doing is providing inputs for the video address 0 to video address 6, and to do that it's actually going to take CA0 to CA7, or depending on what the value of the graphics mode is, in character mode it will start at CA1, in all the other modes it will start at CA0. So what I'm going to do is to show you the configuration files for the programmable logic devices. For the first one I'm actually using a slightly smaller PLD, so this is a 16V8, so it's not quite so many pins. I think this is a 20 pin device rather than a 24 pin device, and there has been a shortage of the larger devices, so I had an opportunity to buy a number of these, so I've been trying to use these smaller ones. What I've done here is defined a pin layout that hopefully matches as close as possible to the existing pin layout of the existing buffer chips, and then we've got the rules and things that I've defined in the spreadsheet have now been copied into here. Well, you don't have to maintain the spreadsheet, I just find it easier to have it all in one place so that when I'm making changes I can actually look at multiple configurations all in one go rather than switching between the different files. So what we're going to do first of all is use WinCUPL to compile this. So all we're going to do there is to do the compile, and it's just going to ask me to add it to the project. Compilation was successful, and what this is going to do is to generate a JED file, a JED file. What I have done as well is used Inkscape to define some custom chip labels. So you can see this is the layout for this particular one, it's slightly smaller. I've done the other chip layouts for the second CPU and the CRTC1 and CRTC2 chips. What I'm going to do is I've already labelled out the chip, and I'm just going to put in the first PLD into the programmer here. Then we're going to go into XG Pro. So I've selected the smaller chip here, then we're just going to go and load the JED file. So this is the one that we've just compiled here. We're going to program it. Just wait for that to program. And what I've also done is I've made use of XG Pro's facilities that allow you to do tests. So what I have done here, if you click on this little symbol here in XG Pro, you can define tests. There are a number of tests for all the standard chips, but you can define your own ones. So what I've done here is for our ATF16 V8 for VR CPU 1, I've actually defined a number of tests. And these things are doing things like checking to see that all the values are high, low, and also that they go high impedance. So when the output enable is not enabled, then these should all go high impedance. So what this means is you can test the chips more easily than you could as if it was in circuit. So although it takes a bit of time to do this and go through all these combinations, I found it easier to do this in the tool here than it is to go through and try all these combinations actually when the chip is in the circuit. So if you get this lot working, there's a good chance it'll actually work in the real circuit. So I just hit test here, everything comes back normal. If there was a failure somewhere, if so a value wasn't quite right, then it would highlight the failures in red, so it's quite easy to see what's going on. So I've done this for all the other PLDs as well, but I'm not going to show doing all of these because it would just take a bit too long. So what I've done then is we've done the first PLD. What I'm going to do now is just go off and do the other 3 PLDs, and then we'll come back and look at what changes we need to make to the board. Okay, so I've finished programming and testing all 4 PLDs, and I've just put them in a breadboard here with the labels on just so that I don't damage them before I put them in the breadboard. So what I'm just going to look at now is where these are going to go. So we've got our CPU1 and CPU2, which is the the 24 pin version, and then we've got the CRTC1 and the CRTC2 versions. Now where these are going to go are on the board over here. The CPU address multiplexers are going to go here, so this is where the two buffers are, and there is a CRTC2 and CRTC1 are here as well. Now the only issue is going to be, as I think I might be a little bit tight to squeeze it in, so I might need to shuffle things around a little bit to fit this one in here. Hopefully I'll be able to put things in so that some of the existing wires and things, so you see here that there are the buses are being connected up here. I should be able to do it so that I won't have to move things around too much. Before we start making the changes, I'm just showing you the previous version of the Nanocomp schematic, so you can see that there were the buffer chips here. So these were the 74LS541 buffers here, and they were basically hardwired for the input lines from the CRTC raster address lines and the output memory address lines for the CRTC, and then there's also the CPU address lines A0 down to A13 PA0. Now for the high-res graphics mode, these were hardwired to that configuration. For the character display, then they were also hardwired to the character display. So what we're going to be doing is swapping out these 4 chips here for the PLDs, which have been configured to be multiplexers. So what we're going to need to do is to go into KiCad. So this is KiCad, and I've already updated this, and what we can see here now is that those buffer chips have now been replaced with these PLDs. So we've got a PLD here now that is receiving the various memory address lines from the CRTC, all the raster address lines, and we've also got our graphics mode and even the clock signals, the QB and QC, which are all needed for that one. And then when we go down to this one, we can see now that we've got the higher address lines, and these are going off to the VA7 to VA14. And then as we go down to the bottom here, we can see this is our CPU1 chip, which was our ATF16V8. And we can see here this is taking in the A0 to A7 lines, just uses the one graphics mode input, and this switches between whether or not VA0 to VA6 are mapped between A0 to A6 or A1 to A7, which is needed for the character-based mode. And then down here we've got the same thing. So the input lines are going to be an amalgamation of the 3 modes, and then the GM1 is all that's needed to switch between the different configurations for the CPU, whereas for the CRTC we need to distinguish between the character mode and the 2 graphics modes because the mapping will be different. But once we put these changes in here and wired up the various pins here, we should be good then to be able to switch between character mode and the high-res graphics mode in software. So what I'm going to do is I'll just go and speed up that video as I make all the changes, and then I'll commentate over it. And so when we come back, hopefully what we've done is put in the multiplexers, and then we'll fire it up to see whether or not we can switch between the character mode and the high-res graphics mode. So first of all, take out the old buffer chip and put in the new PLD, just checking up the right-hand side address lines match up okay, and just putting in the output enable. Now in fact the left-hand address lines there need to move down one for the video address output there, so just change those. Now we need to make sure we've got the graphics mode 1, and we'll also be then putting the graphics mode 1 to go down from the second to the second chip, and also address line 7 as well. We're moving down the other address lines to line up, and then we need to put in the page address 0 and page address 1 into there as well. So that's page address 0, page address 1 I think is already available there. And we just need to move the higher address lines down a little as well. I just need to put an extra wire in there because it's not quite long enough. So once all of those higher address lines are, we then just making sure the output enable's hooked in. So now we're going to take away some of the ribbon cables and put in our new PLD there, take out the original buffer. Just need to shuffle this up a little bit so that the output lines line up with the existing green address lines. So just getting that lined up there. Just need to move that output enable blue line wires just out of the way a little, tidy that up. Now we also need to put the address 7 line is actually now handled by this lower chip, so we just need to make sure we've got the video address line 7 in there. Now we need to make some space up top here for moving up the PLD, which is just below the data lines there. So we're just moving the data bus up by 1 hole and having to shuffle those wires over on the right hand side, and the top blue wires, the read write as well. Just shuffle those other wires up, so that should allow us now to move that chip up, and we also then shuffled all the wires up along with it as well. So now we're going to be wiring in the various CRTC memory address lines, so we just need to sort out those. So this is the memory address 0 all the way up to, I think, memory address 12 I think we're using here. It's just wiring those into the input side of all the multiplexers, making sure we get those right. Okay, then there's a few extra lines there. We're actually hooking up the 3 address lines. So that's all the PLD changes done. I think I've done most of it right, but what we're going to do now is to run up the Lunar Lander game just to see if that produces any output at all. So I've started up the Nanocomp. We're now looking at the VGA screen capture, and if I now just run up the Lunar Lander game, the screen will clear. So that's good, at least we've got something there, and let's see what comes up of the Lander game. I need to take some of the debug statements out because that's what's slowing it down a little to start with. Okay, so we're getting something there, but obviously what we're seeing really is there looks like probably some memory addressing problem, because some of the pixels are kind of shifted across probably by about sort of 16 or 32 characters, something like that. So it looks like there's probably some sort of memory addressing problem. So what I'm going to do is to have a quick look and see whether I've got some wires crossed or something like that, and then we'll come back and see if it looks any better. But we are getting a signal, so it just looks like there's some sort of issue there with the offset between some of the lines, which is causing the problem. Okay, so I had a quick check and there were a few issues and things I had to troubleshoot, but I've managed to get the high-res graphics mode working with our new PLD multiplexers. So you'll see the default screen after power on with the graphics mode, and what I'm just going to do now is to run up the Lunar Lander game. As it initializes, there's some debug messages coming up on the terminal emulator, but once those have done, then we should see. So you can see there the 2-color 640 by 480 graphics appear to be working there. There is a little bit of snow, which we're going to look at in some future videos to sort out the timing between the CPU accessing the video RAM and the video card accessing the RAM. But you can see there that the image is pretty decent and is what we had at the end of the previous main video, Lander video number 12. So that's working okay. So what I'm going to do now is to go in to look at the character-based mode, and we're just going to turn off the Nanocomp, and one or two configuration changes I had to make, which I'm going to need to add to the schematic, and I'll talk about those in a few minutes. Okay, so this is the schematic from one of the later character mode versions, and what I found was that the color latch that we have here is clocked here by SR latch, which comes from one of the main PLDs for doing all the timing. So that's in character mode. But if we look at one of the schematics from the later graphics modes, we can see that this clock in fact has been replaced by this signal for the Y3 color latch here. And so what I'm having to do to get the character-based mode to work is just to hardwire this in, and what I'll need to do is to add configuration to this into the PLDs, so that when we switch between the modes, then the signal for this particular clock here, or the latch signal, is actually going to come from these two different places, where it would be the SR latch signal for character-based mode or this other signal for the graphics mode. So we'll just have a look at the Nanocomp. I'll run up a test program and run up Tetris just to see that everything's working okay. So this is the VGA capture card now, and if we power on the Nanocomp, so you can see here we're now getting our Nanocomp power on message here, so that's good. That's what we'd expect. And what I'm just going to do now is to load one of the basic character test programs. So this is one of the sort of test patterns I was using. And you can see there that apart from the tail end of the line, that one or two of the pixels at the end may be just missing a little bit, but this displays perfectly okay on an LCD monitor. So it's just down to some of the timing differences between the capture card and the monitor. We can see here the character mode seems to be working okay. We've got our colors and things, and this is 80 columns across by 30 down. And then what I'm now going to do just is to load up the Tetris game to see whether or not that's working. So just reset it and load. Okay, so that's so I'm just going to run that now. So get S to start. So you can see now that the Tetris game appears to be working okay. I can remember what the keys are. So, yeah, 1 is the drop key, there we go. 2 is the swap, and so appears to be working okay. Okay, so we've done most of the step 8 that we need to do here. So we've added our program or logic device multiplexers for both the character and graphics modes, both the CPU addresses and the CRTC addresses. And we've been largely able to switch between character mode and high-res mode. There was one bit of manual configuration to do with the color latch signal that I'll do some work on, and I'll update the schematics. So in the next video, what we'll be doing is adding the video DAC, making some of the changes to add it to the data bus and the chip enable, and we're going to sort out some of the additional multiplexing options and things that we need for the color multiplexer, and any other control signal changes and things which I discovered during the debugging process that we've just completed. So what we've done here, we've done this multiplexer here. What we're going to be doing in the next video, we're already using the page register and the graphics mode settings. So what we're going to be doing is adding another latch to allow for the 8-bit color data to go straight into the multiplexer that we're going to add here. And then we're going to be adding the video DAC as well, which is going to have a constant current source to drive the voltage levels for the VGA output. So that will be in part 3. Well, hopefully we'll then complete that and get it to output the sample Doom graphic that I showed in the first part of this video. So if you don't want to miss out on future videos, please hit subscribe, and if you found it interesting, please hit like. Thanks for watching.